Welcome to the Hammer Museum. I'm Claudia Bester. I'm the Director of Public Programs here, and I'm very happy to introduce tonight's talk by Sebastian Copeland. Sebastian is an award-winning photographer, author, filmmaker, extreme outdoor adventurer, and environmental activist. After attending UCLA Film School, Sebastian launched a very successful career shooting ad campaigns and celebrity portraiture for high-profile magazines like GQ, Vanity Fair, and Interview, as well as directing music videos and TV commercials. His love of the outdoors, extreme sports, and his passion for photography led him towards a career that has turned out to be less Harper's Bazaar and more National Geographic. His own personal commitment to fight for the protection of the environment has led to a relentless pursuit of a sustainable future and has taken him around the world as a filmmaker, photographer, lecturer, activist, educator, and advocate. Sebastian uses his photography as a medium for his activism. He's led many expeditions to the polar regions. In 2006 and 2007, he spent 6 weeks aboard a scientific research icebreaker in the Antarctic Peninsula. In 2008, he and his partner Luke Hardy took a group of 9 children for a month to the northernmost Canadian Arctic as young ambassadors of the Arctic. In 2009, he led a mission to the geographical North Pole. He and his partner Keith Hager walked 700 kilometers to commemorate the centennial of Admiral Peary's 1909 expedition. And there's a documentary film about that expedition called Into the Cold, A Journey of the Soul, which tells that story, and it's absolutely remarkable, and it also lays out the precise step-by-step details of how does a person even prepare or conceptualize an expedition like that. In May 2010, he and his partner Eric McNair Landry left from southern Greenland to cross the 2,300 kilometers of its ice sheet using skis and kites, and reached the northern tip 41 days later, setting a new world record for the longest distance traveled on kites and skis over a 24-hour period. For the South Pole's centennial season in 2011-2012, again with Eric McNair Landry, he led a 4,100-kilometer transcontinental crossing of Antarctica by skis and kites, setting 3 world records over the 82-day expedition. In recent years, Sebastian has focused his energy on becoming a voice in the fight to bring awareness to the crisis of global climate change. He's spoken out about global warming at the United Nations, the World Affairs Council, and the General Assembly on Climate in New Orleans. He was named German GQ's Man of the Year for his environmental leadership and received the Founders Award from Global Green USA in 2008 and its most prestigious Gala Award in 2010 for his environmental stewardship. His first book, Antarctica, The Global Warning, had forewords written by Leonardo DiCaprio and Mikhail Gorbachev and won him the International Photography Awards Professional Photography of the Year Award in 2007. His second book, Antarctica, A Call to Action, gives tangible ways that each of us can make a positive difference to help reverse global warming through small changes. And we will have copies of both of these books as well as the documentary for sale in the lobby, and I'm sure Sebastian would be happy to sign a copy for you if you like. Sebastian is truly a master photographer. His prints have appeared in solo exhibitions at the United Nations, the Peabody Essex Museum, the Field Museum in Chicago, and the Council on Foreign Relations, among others. He's also on the board of directors for Global Green and for Shine On Sierra Leone, a non-governmental organization providing educational platforms for the children of war-torn nations. Sebastian continues to lead expeditions to remote corners of the globe to spread consciousness on global warming. So without further ado, please join me in welcoming Sebastian Copeland.
Thank you very much. Let's assume that somebody dear to you, let's say your child, displays persistent and growing signs of chest pain. You're alarmed, you go see a heart specialist. The heart specialist tells you that your child most likely needs heart surgery. You're understandably alarmed. You seek a second opinion, and then a third, and then a fourth, and a fifth. Over the course of time, you seek about 100 opinions. 95 opinions come from heart specialists who all tell you that your child needs heart surgery. Of the 5 who are not heart specialists, let's say 2 are dentists, One is a chiropractor, and the other two are insurance adjusters. The chiropractor tells you that your child probably needs a spinal adjustment. The dentists have opinions, but admittedly they tell you that they're not heart specialists. And the insurance adjusters tell you that heart diseases are part of the natural cycle of humanity. Some people get them, other people don't, and that the surgery is very expensive, and that, by the way, heart surgery makes doctors wealthy. If that was your child, and if you had compiled this consensus, this extensive consensus of opinion, what would your action be? Well, if you're answering spinal adjustment, then your thinking would be about in line with you'd be applying about the same logic that prevails across societies today and governments worldwide in the face of overwhelming scientific evidence linking climate change to anthropogenic activities. We go to war with a lot less evidence than that. While private interest groups are busy scrambling the airwaves with counter-information propaganda, leaving a trail of confusion and galvanized partisan politics, the Earth's climate and the temperature rises fastidiously, little increments at a time in temperature. History judges harshly. It's difficult to look at the 20th century history and not be baffled by the collapse of democracies across the world and the reign of fascism that has stained our history over the course of the last century, from Asia to Africa, South America, and of course in Europe. Most troubling is the question that probes at the common nature of social apathy in the face of depraved governance and abject policies. In fact, if you look at cultured and educated societies like Germany in the 1930s, like Yugoslavia in the 1990s, you have to wonder, how does a sophisticated, educated, forward-thinking society implicitly lend their support to regimes of terror, of war, of genocide? Is it ignorance? Is it opportunism? Is it fear? Is it denial? How does this relate to climate change? Well, in the year 2100, historians will look back on today's industrial societies and search for answers to the root of their condition. A century of carefree development has set humanity on a collision course with nature, and recent years have shaped a divisive fork in our attitudes towards world development, one that pits the old world, the fossil fuel energy world and economy, against the new world and renewable energy, one that pits short-term gains against global welfare, conscience against greed. And while the jury is out on a time frame as to whether or not the world will unite and commit to market transformation towards a sustainable economy, in that virtual courtroom of the future, one of two scenarios are likely to emerge. This generation will either be heralded for its socioeconomic adaptability and its capacity to come together in its finest hour to address what is sure to be the gravest challenge ever facing humanity today. Or historians will look at us and indict us on our short-sighted resistance to change in the face of those grave signs of environmental collapse and blame us for the food scarcity, social chaos, international conflict, and the refugee culture that spirals out of it. Empires don't just collapse. Carthage, Rome, Athens, Prussia, all once wielded incredible power. There's jurisdiction stretching far and away across vast lands. but all fell, bewildered by their lack of foresight. And history helps us identify the growing signs of social erosion, and almost without exception, they all point to unsustainable expansion and the addiction to growth. The unbridled desire to spread culture and acquire wealth and power invariably leads to overtaxing resources, either natural or human. And we live in an environment where growth is expected to be permanent, and perpetual growth in a finite environment is tantamount to suicide. Humans have destroyed their environments before. I just realized the curtain's not open. Could we open the curtain? There we go. There will be some slides, I promise. Humans have destroyed their environments before by misalignment and lack of adaptability, but these were tended to be geographically contained. Mesopotamia, for instance, the cradle of civilization, an environment that gave us language and math, modern means of irrigation. And with unsustainable irrigation practices, Mesopotamia, which used to be a thriving ecosystem and farming environment, was turned into the arid wasteland that it is today. In the 12th century, the kingdom of Angkor, one of the most powerful and advanced cultures in Asia, the largest urban settlement with over 6 million people, was brought to its knees by its lack of sustainable development and overtaxing of the land, its resource and its water resources. Prophetically, what remains today of Angkor, of course, is ruins, the vestige of that civilization overtaken by nature, which claimed back what it had once lost. As Claudia said before, I have spent a lot of time traveling the polar regions. I crossed the Arctic Sea, I've crossed Greenland, I've crossed Antarctica. And there are generally two questions that mostly come to me by people. I often ask, why do I do it? And the next question is invariably, where do you go to the bathroom? The second question is what we call the trade secret. But the first question is interesting because I want to share with you a little film that in many ways illustrate why I've taken such a great interest in this little planet of ours. This is the last 130 years in 26 seconds. Globally, the world has warmed up by about 0.8 degrees Celsius or 1.5 degrees Fahrenheit over the last century. In the Arctic, that number has reached 4 times that much. It gets really interesting here, just about at 1980. You start to see the temperature shifts happening. This is 1990, 2000, 2010. The planet has a fever, and it looks very likely that humans have something to do with it. From 1950 to the end of World War II, the baby boom, we see an explosion in quality of life and growth in demographics, explosion in energy use as well. In developed countries, we've roughly grown 10 times our footprint over the last 100 years. 100 years ago, we got 1.5 billion people. Today, we've got about 7.1 billion people and growing at about roughly 80 million people per year. Our lifespan in the US has just about doubled. And by 2050, more than 6.5 billion people will live in cities. We've grown like a virus. And every indicator points to the fact that we are exceeding our carrying capacity. You may be familiar with this graph. Over the last 850,000 years or so, we've never exceeded an average of 280 parts per million of carbon dioxide into the atmosphere. This is a concentration that goes up and down over the course of the centuries. And in the last 50 years or so, that number has gone from 280 parts per million to about 394 to 395 parts per million and counting. And for the first time this year, the Arctic has reached a symbolic mark of 400 parts per million, hovering over its ice cap. That's 400 400 parts per million over what's never grown beyond 280 parts per million. And of course, a graph of temperatures goes in line with that. The greenhouse gases that we can track are quite interesting according to human events. You can see here, this is the end of the first industrial revolution. By here, 1885, the invention of the first car, the Mercedes-Benz, and a taxing on resources, hydrocarbon fuel in particular. The Great Depression, obviously a relaxing of our needs on hydrocarbon fuel, and a few years later, a reduction of greenhouse gas emission in the atmosphere, the end of World War II here. After great deployment of machinery and military apparel, the world comes back to reason. There is obviously a lot less carbon put in the atmosphere. This is the Arab embargo, in the 1970s, and you see a severe drop again in the greenhouse gases in the atmosphere. This is the end of the Gulf War, actually around the Gulf War time period, and I guess, again, a drop in greenhouse gases. That graph mirrors essentially the global surface temperatures that you can see from 1880 to present day at 0.8 degrees Celsius increase in the last century. We have lived in the last 30 years or so a constant record-setting period. 1996 and 2005 were the two warmest years on record. In fact, we've been breaking all records. November 2012 marked the 333rd consecutive month of above temperature average for the 20th century. 2012 was also the 427th consecutive month of ocean temperatures above 20th century average. 2000 to 2010 was the warmest decade on record, and of course 2012 was the warmest year in the US on record. This is since instrumental record in 1880. The average temperature this year was 3.8 degrees Fahrenheit, or about 2 degrees Celsius above 20th century average. Everything is growing in record-breaking temperatures. 95% of the world glaciers are receding, and I'm going to leave out today the ocean acidification, the hydrological cycle, the forest, the ground contamination, the genetically modified food, as well as other anthropogenic contributors to the systematic breakdown of our ecosystem out for now, because otherwise this presentation would be going on until next weekend. Remarkably, and for the most part, this is just about the actions that we've been taking in light of those very troubling statistics. In spite of a campaign of awareness in the last decade or two, elected officials and public opinions have mostly chosen to ignore these issues. These are dramatic statistics. You have to wonder, why do people persist to ignore them or to deny them? Because it doesn't seem to be affecting them directly. We're ready to invest in our children's educational fund and college fund, but we're prepared to bankrupt their future because it seems so distant and so difficult of access. It doesn't seem to be impacting us directly, and certainly when you're a decision maker in politics or in business, you don't want to be the one breaking the bad news. And generally speaking, that's really what it breaks down to. It doesn't seem to have a direct geopolitical consequence immediately. In fact, we've seen that the dramatic drought that occurred this summer in the US brought corn commodities, for instance, up 40%. Evidently, that is impacting our economies. But I want to focus for a moment on the droughts and fires in Russia in the summer of 2010. In 2010, unusual drought is overtaking Russia. Fires break up from Moscow to Siberia, over 5,000 in total. The burn rate of Russia's agricultural environment brings its grain production down by almost 30%. Russia, Kazakhstan, and the Ukraine account for about 1/4 of the world's export. You could see the fires burning from space. It was quite remarkable. I don't know if any of you remember that. But by the midsummer, the grain export is down 30%. The price of wheat has gone 66%, has risen by 66%. And Putin decides to put a freeze on all exports. Again, Kazakhstan, Ukraine, and Russia, the fourth greatest exporters of grain in the world. On top of that grain, thousands and thousands of acres are burned. And all the hay and wildgrass are burned, which is basically the feed for cattle. And the Russians are forced to turn to barley to feed their cattle. And consequently, the price of milk-related product and meat, of course, goes up. And the freeze on export is impacting communities and countries all around Europe, as well as North America and the Middle East. Months later, civil unrest breaks in Tunisia. A man sets himself on fire in a food market as a testament against high food prices. And this sparks the powder box of what became known as the Arab Spring. Studies shows that in El Nino years, which tend to be a lot drier and a lot hotter, that conflicts in tropical regions doubled compared to El Nino years, which are cooler. Climate has a direct geopolitical consequence today, and it has to do with the relationship of cause and effect, the connection between phenomena happening in nature and their geopolitical consequences. There are 30 million species inhabiting this Earth, all for the most part interconnected and interdependent. We all breathe the same air. We all experience the same temperature shifts. We are all impacted by chemical changes in the atmosphere, and the entire delicate balance of life on this planet and its hydrological cycle is impacted as a result of it. I'm going to show you now a map of the sea ice in the Arctic, because if you want to know what's going to happen in the world in 30 to 50 years from now, you need to look no further than the poles. The Arctic has seen reoccurring ice for the last 47 million years or so, consistent with a pronounced decline in CO2 levels. The last 12 to 13 million years or so have seen the largest extent of ice, with the last 2 to 3 million years seeing the greatest expansion of ice in the Arctic region, again consistent with the Earth's cooler cycle. You can see there that the ice extent in the Arctic has been dropping considerably relative to 30 years ago. The albedo effect, the reflectivity of the sun's energy off a bright surface. If you walk out in the middle of a very hot summer day wearing a black shirt, you'll understand immediately the nature of the albedo effect. If you wear a white shirt, you'll feel considerably cooler, a lot more comfortable than the black shirt, which will be absorbing the sun's energy. Well, the same, of course, applies to ice and to oceans. The sun's energy hitting ice tends to be reflected back into the atmosphere. As the ice disappears, that sun gets absorbed into the ocean. In fact, that sun energy creates what's called a positive feedback. In the last 40 years, the first 700 meter layer of the Arctic Ocean has warmed by about 1/3 of a degree. And of course, any warming in an ice environment bodes poorly for the ice. If the ocean and air temperature rises, the ice extent is sure to suffer. And not surprisingly, with this graph, you can see that the last 15 years have seen the 15 smallest ice index in the Arctic, with 2012 showing the smallest index yet. I went to the North Pole. This is me at the North Pole in 2009. It was a childhood dream of mine. I wanted to follow in the footsteps of Admiral Peary, who reached it first in 1909. The Arctic, of course, for the most part, is a crust of floating ice over the ocean, only a few feet high. It's basically a floating frozen surface. It's a remarkably rugged and tough environment. It's cold and humid, but it's pristine and beautiful. And it's considered to be one of the most difficult expeditions in the world. Any explorer wants to reach the North Pole on foot. I was privileged enough to fulfill my childhood dream in 2009, but it's pretty clear today that children dreaming of reaching the North Pole will not likely be able to do so within the next 15 to 20 years or so. Children being born today will not fulfill that ambition should they choose to have it. The Arctic summer ice has lost about 11.5% of ice every decade since 1979. Its greatest seasons of ice loss were in 2006 and 2007, with 500,000 square miles of ice loss, which is the equivalent of Texas and California combined. The sea ice cover is about 47%, almost half of the surface that it was 30 years ago, with 2007, 2008, 2010, 2011, and 2012 being the lowest of the ice index. NASA tells us that the Arctic has warmed by 1.5 degrees to 2.5 degrees Celsius in 2012, with some areas reaching 3.5 degrees Celsius. It's remarkable because that is what is impacting the ice in the Arctic. Its reduction of index has to do with the albedo effect. And of course, one of the most important aspects of ice in the Arctic has to do with thickness. The ice thickness has everything to do with its structural integrity, its ability to sustain variabilities in climate. The winter sea ice in the Arctic in the 1980s was about 12 feet in depth, which is more or less what it was when Admiral Peary reached the North Pole in 1909. In 1980, it was about 12 feet in depth. Today, it's about 4 to 6 feet in depth on average, and rapidly decreasing. The Arctic ice is essentially like a breathing lung. In the winter, it expands. In the summer, it retracts. But really what matters, what is most important, has to do with its thickness, because its thickness has everything to do with how long that ice is going to be sustaining warming trends. In 1980, the Arctic was comprised of about 80% of what's called multi-year ice. This is ice that is 5 or 10 years in age. By virtue of that, it survives the summer spells and the warmer spells, sustains itself over all seasons, and remains again there for the winter. Over the last few years, the last 30 years or so, we've seen that index shrink and get smaller and smaller. And what that really means is that even while we see that ice extent in the graphs that I've shown you earlier, what is going to happen is that at some point that is going to happen quite soon, the ice is simply going to go, because it's gotten so thin that one hot summer spell will virtually destroy the summer sea ice in the Arctic, something that hasn't happened in a million years. The IPCC, in fact, is predicting that the ice could be summer-free by as early as 2013, this next summer season, or certainly between 2013 and 2040, which is about 30 years ahead of its initial prediction. Again, an ice-free Arctic would not have happened in about a million years. Of course, outside of the positive feedback affecting global temperatures, this is having a direct impact in the habitat and migration of migratory patterns, that is, of its whole ecosystems, from birds to whales like these belugas here, seals, of course, and the poster child for climate change, which is, of course, the polar bear. Less food for mothers means less food for the cubs. Mothers have, like humans, a 9-month pregnancy cycle, and bear numbers are quickly at risk if food sources get scarce. And food sources are, of course, measured against the extent of the sea ice, because that is the hunting ground for polar bears. The number one actor in terms of global geopolitical consequences economic consequences around the world is Greenland. Greenland is essentially the central actor in terms of global impact. It's the second largest ice sheet in the world. I've crossed Greenland from south to north in 2010, did a 2,300 kilometer crossing of this beautiful and pristine landscape, 2 miles of ice depth sitting on top of the largest island or the smallest continent in the world. It is met with fierce storms. This is a hurricane that I sustained over 7 days and 6 nights with 100-mile-plus-hour winds. And other times it's completely dead still and dead calm, such as this day there. Greenland sees a variety of different temperature shifts, of course, and often sees areas reaching temperatures above freezing. This has been going on for a very long time. What's happening now is that we're seeing more and more of those days, and when the ice reaches above freezing on Greenland, it creates river flows, and these river flows gather on, again, an ice sheet that is 2 miles in elevation into what's called melt ponds. And these melt ponds gather essentially from a multitude of different river sources. And what's happened over the last 30 years or so, and more is a phenomenon where we've seen this melt pond water, the melt water on the surface of the ice sheet, gather into these lakes and eventually dig a hole, if you will, into the ice sheet. And that hole gets deeper and deeper until it actually reaches all the way down to the bedrock in what's called moorlands. And these moorlands, like this one in East Greenland, lubricate the bottom of the ice rock. Why is that relevant? Because the more moorland there are and the more water lubricating the bottom of the ice sheet, and the faster the movement of ice towards the ocean. Ice is always more or less in movement. You have to look at ice as essentially a liquid and not so much a solid. It acts essentially in many of the same ways that a liquid would, except a lot slower, of course. And when the bottom of the ice sheet is lubricated by the water gushing down to these moorlands, what you see is a more rapid movement of the ice, and that ice, of course, is headed to the sea. Why is that relevant? Because that ice sits on top of a continent, and the water that gushes into the ocean has a direct connotation with ocean rise. In 2012, this year, for the first time in instrumental record, Greenland saw 97% of its surface melt. In other words, 97% of this continent, 2,600 kilometers in length, saw melt simultaneously. This was an unusually strong ridge of warm air that hit in May, and that led to a melting at the summit station 2 miles up on top of Greenland, and a persistence of warmer spell led to unprecedented melt. Had I traveled in Greenland in 2012, I would not have been able to complete my expedition because you simply cannot travel in wet snow. The ice sheet is gaining in mass and elevation, so this is what you may hear a lot from pundits. This is true both in Antarctica and in some areas of Greenland. Some people will tell you, well, if the ice sheet is gaining in precipitation and in mass, then surely this is obviously not because the climate is warming. Well, Greenland, as well as Antarctica, sits in elevation. It is about, as I said, about 2 miles in elevation. So needless to say, at that height, things remain relatively cold, generally speaking. But that precipitation has everything to do with a warmer climate in the coastal region. More precipitation is essentially more evaporation traveling over the surface of the ice sheet and then dropping onto the ice sheet. And so what's happening is that the coastal region themselves are melting quicker and are precipitating into the ocean, all the while the center of the ice sheet itself may, in fact, see growth in mass. But the bottom line is that there is a mass balance a negative mass balance of about 200 gigaton of ice on Greenland per year. What does 200 gigaton of ice represent? Of course, this is an abstract number, and that represents about a millimeter of global ocean rise. Can we deal with a millimeter of global ocean rise? Yeah, most likely we can. We have. The real problem about that millimeter is that it's a number that is accelerated, that is not obviously centered just on Greenland, but that we see as well happening in the Antarctica Peninsula and some of the coastal areas around Antarctica. In fact, the ocean is rising by about 3 to 4 millimeters a year and increasing exponentially rapidly. We're seeing a rapid rise of glacial pour into the ocean over the course of the last 30 years. So that negative balance of 200 gigatons of ice in Greenland starts to spell an agenda that is vastly different from what it looked like 30 years ago. We've seen in the last century about 12 to 18 centimeter of ocean rise, which is fairly marginal. But computer models predict that by the end of this century, we will see, instead of 12 to 18 centimeters, which is about a half a foot, we'll see 4 feet of ocean rise by the end of the century. We lose 100 feet of global coastal area for every foot of rise. So 4 feet of ocean rise equates about 400 feet of global coastal areas. It's very substantial. Economically, of course, if you live in Malibu on the coast or if you live in Santa Monica, I'm sure you have a very good idea of what that could do to your property. And of course, a lot of farmlands, a lot of port land, industrial ports and economies are centered in the coastal regions. 4 feet of ocean rise, incidentally, is enough to flood the plains of Vietnam. Vietnam is the second largest rice producer in the world. And if the Vietnam rice paddies were flooded with salt water, you can get a general idea of what this will do to food commodities, what this in fact will do just simply to food for human beings and the social chaos that may ensue with a shortage of food commodities. 4 feet is a conservative estimate. Other models point to 20 feet of ocean rise by the end of this century, which is a combination of both ocean pour and what's called thermal extension, which is the mass of water expands as it warms. So this is, again, a positive feedback. As the global temperatures rise, the ocean also expands, and in expanding, it steals away from coastal areas. Models up until very, very recently only pointed to a 2 degrees Celsius rise in global temperature. In fact, it's recently that global governments have looked at 2 degrees Celsius as potentially a benchmark, not to allow us to go beyond that. Why did models only compute up to 2 degrees Celsius? Because that seemed unimaginable even 10 years ago. We never considered that the world could actually warm up to 2 degrees Celsius more. Now it seems pretty evident that by mid-century we may actually reach that mark. So we're starting to look at computers programming models, which are very, very complicated algorithms of all types of input data. And they are starting to input now predictions of 3 degrees Celsius of increase. And a 2 degrees Celsius increase already would be a complete remapping of the world's coastal areas. But with 3 degrees Celsius, you would be looking at a complete redrawing of the world that would look significantly different from what it looks like today. Recently, some scientists have started to look at what the world could potentially look like with a 4 degree Celsius increase. A 4 degree increase would be so dramatic, so incredibly unprecedented for any type of biological life on this planet, that some areas of this planet, our planet, would reach temperatures in excess of 170 degrees Fahrenheit, which would preclude entirely the possibility for biological and, of course, human life. The fact that we're actually looking at what 4 degrees Celsius could potentially look like in itself is very alarming. The last ice age, which happened about 110,000 years ago, occurred with a shift of 4 degrees, incidentally. What happened is that what's called a thermohaline circulation, which is the currents that distribute warmer water from the tropics into northern Europe and brings cooler water to the tropics, and it has been a regulator of global temperatures for millennia. 110,000 years ago, in the last mini ice age, the thermohaline circulation collapsed. And with it, Europe was itself sent into mini ice age. If you want to know what's going to happen globally, again, you need to know to look no further than the poles. And the same goes for Antarctica, specifically the peninsula. Antarctica, of course, is very different from the Arctic. It is a continent as opposed to a frozen ice cap. It sits on land. It's, in fact, the highest continent in the world. It sees seasonal expansion of ice as well, but it's much less of a factor in terms of albedo, because while Antarctica doubles in size in the winter, most of that happens in darkness, because the southern hemisphere in the winter is, of course, is void of light for much of its winter. So again, some naysayers will talk about how the sea ice in Antarctica may be slightly increasing, and I want to bring this up because, as an argument, this is invalid as far as a balancing act between the North and the South. The fact that a Arctic sea ice may have a slight increase in extent in the winter period has zero effect on albedo because it sees no light, and in fact has zero effect on globally cooling the planet. Antarctica also sees, as Greenland does, a slight increase in its precipitation and therefore a slight increase in its ice mass and some of its high elevation. Some of the plateaus in Antarctica, which I've traveled across, average at about 12,000 feet in elevation, or about 3,000 meters. So at that elevation, of course, it's still very, very cold. In the summer period, the average temperature never really gets warmer than -20. But it's not the areas that are really impacting global ocean rise. It's always going to be the coastal areas. I crossed Antarctica from east to west last season, did over 4,000 kilometers on skis and kites. This is my partner and I at a place called the Pole of Inaccessibility, or at least the Antarctica Pole of Inaccessibility. It is considered the most remote place in the world, essentially the farthest point from any coast in Antarctica, and was the site of a Russian base station abandoned since 1958. That station sits, incidentally, about 15 feet below our feet there. Over the last 50 years, the ice overtook the station. And before leaving this godforsaken place in 1958, the Russians left a bust of Lenin sitting on top of the chimney, and that's the third character in this photograph next to us to the right. Antarctica is a very, very difficult environment, extraordinarily beautiful, of course, because it is, at least seemingly, it's untouched, but very, very cold. It's met with tremendous winds as well, what's called the katabatic winds, that can gain speeds of up to 200 miles per hour. We kite skied across it, and this is towards the end of the trip as we're approaching the coast. Otherwise, there would be no mountains. The ice sheet is essentially swallowing all of the landmarks, including those peaks. Eventually, they basically get swallowed by the ice mass, which raises up to 12 to 13,000 feet. This is some of the landscape in Antarctica. The sastrugi, which follows the prevalent wind directions, that is, and creates these beautiful, if extraordinarily uncomfortable, ridges to ski over. Not great on the knees. This is us at the South Pole. This is the ceremonial South Pole, the place the axis under which the Earth rotates. For all intents and purposes, if you were to walk around this ball that's there, you would be crossing every single time zone on the planet. Antarctica is, in its continent interior territories, is rather stable. It is the peninsula that is showing the gravest signs of instability due to changing climate and a warming climate. In fact, that area, the red area that you see here with that tongue that extends towards South America, is seeing temperature increases that are 5 times the global average, almost 1 degree Fahrenheit per decade for the last 50 years. As a result of those warming trends in the last, that we actually haven't seen in that region for at least 12,000 years, that is, in the last 50 years, they have been unprecedented. We lost the Larsen A ice shelf, which is the one up just below the Gustav ice shelf up there. In 1995, it collapsed. The Larsen B in 2002, the Wilkins collapsed as well, and whole sections of the Ronny ice shelf, which is a little bit below, down there to the right, is showing fissures this season. And ice shelves are the protection barriers for glacial melt and, incidentally, ocean rise. I'm going to show you now a very interesting animated film, which is given to us by NASA. This is, for the first time, a visualization of glacial flow in Antarctica. Every single one of those veins there are essentially river flows. They're glacial flows, if you will. And this right there is the Ronny ice shelf to the left there. And you can see how this entire continent is alive. It's constantly in motion. It's moving, and it's always moving towards the coast. So those ice shelves that we talked about, the Larsen A, the Larsen B, the Wilkins, the Ronny, the Ross ice shelf, this incidentally is the Ross ice shelf right here. You see the red areas as the accelerated rates of pour, and over here even further, the Ronny ice shelf, which is a massive ice shelf in West Antarctica. And this is a visualization of how ice is actually alive, it's in motion, and it has a rate of pour that we're seeing accelerating. Antarctica, or the peninsula at least, or the coastal regions, are teeming with animal life, which have lived mostly outside of human interaction, at least until 200 years ago. Antarctica didn't see a human footprint until 1821. Now their habitat is endangered as well. We are, in fact, living presently through the 6th great extinction event. Scientific models tell us that we're presently in the 6th great extinction event. There have been 5 extinction events in the last 450 million years. Between the chemical shifts in the Earth's atmosphere, the changes in its hydrological cycle, and the disruption of its seasonal cycle, we will see by the end of the century 50 to 70% of all species disappear on this planet. This is the 6th great extinction event. Extinction events, incidentally, happen very fast generally and typically take about 10 million years to recover. To put this in perspective, anatomically, modern humans are about 175,000 years. So 175,000 years. If you looked at the geological clock of the planet relative to the age of the planet was formed about 4.5 billion years ago. Anatomically, modern humans are 175,000 years. If you looked at the beginning of the world as a clock, humans that would start essentially on January 1st. Humans have appeared on this planet at about 1 minute before midnight on December 31st of that geological year. So 10 million years, geologically speaking, represents very little. Humanly speaking, represents tremendously a lot. So, what to do? We need to stop looking at climate change as an ideological platform. It's a scientific issue with profound socioeconomic and geopolitical ramifications. And solutions are based in technology. We look at We look at engineers to create bridges. We look at generals to wage wars. And we need to look at scientists to give us data that is relevant for our economic development. Martin Luther King spoke of the fierce urgency of now. And the fierce urgency of now is essentially how we should approach a program of reduction of greenhouse gases, and a program of action that will include renewable energy, a carbon tax, and emissions control and offsets, and adaptation, of course. We need to adapt. This is a basis of Darwinian theory. We have to adapt to changing climate, otherwise we will be history. We need to change our ways. And of course, we need to look at forests as the great carbon sink that they are. Finally, we really need to be independent from elite energy sources: oil, coal, tar sand, gas, shale gas, uranium. All those are elite energy sources. Why are they elite? Because they're limited, because they are expensive, and because they're based in a pyramid-shaped economic model that requires tremendous geopolitical investments. The new economic vision of the future is a departure from the second industrial revolution that we live in. And in fact, the solution of the future, if we can get there on time, is already amongst us. We have those solutions, and that solution is essentially the third industrial revolution. The second industrial revolution is dying. Its hallmarks are centralized electricity and combustion engine. They're old, they're outdated. We're already seeing grave changes happening now. All you need to do is the new lineup of everyone's cars, and you'll see that electrical engines are what everybody is bringing to market. And there's a good reason why that is because it's cheaper, because it's more efficient, because down the line, in spite of still requiring energy to power up, it requires a lot less energy than combustion engine, and it costs a lot less, and of course it doesn't put greenhouse gases into the atmosphere. We need to be off carbon energy and off fossil fuel or hydrocarbon fuels by mid-century. We need to switch to distributed energies, because 1 hour of sunlight on this little planet of ours is enough energy to power global needs for 1 year. If we could harness 20% 7% that is, of the wind's energy on this planet, we would create 20% our global energy needs. And that thinking is the basis for the third industrial revolution. I'll go now to this, the smart grid. Okay, in the U.S., 34% of greenhouse gases come from electricity productions. The intelligent power distribution and management of electricity is the future. Right now, the grid is a 1.0 model. It hasn't changed much, essentially, since its creation in the 1880s. Most distribution is manual. Think of it in terms of file sharing in the 1.0 model relative to, let's say, the 2.0 cloud system. In the 2.0 cloud system, cloud computing, each housing unit becomes a source of energy that can intelligently distribute from peer to peer, organized collaboratively, and distributed, and scaled, that is, laterally. So every single housing unit, through geothermal, through solar, through wind, through any number of renewable energy, creates its own energy source, becomes its own grid, if you will, and intelligent can communicate to other units and distribute energy where it's needed. It's always sunny in one place of the planet, or one place of the country for that matter. It's always windy in one place, and it can intelligently distribute that energy where it's needed. A smart grid is improving reliability and security. There's always energy somewhere. It improves operating efficiencies and costs, balancing power generation, its supply and the demand, and reducing the overall electrical system's impact on climate change. Besides, it takes us from dependency from foreign energy and makes us energy independent. Europe, by the way, is already going in that direction. It's committed to a 20% reduction of greenhouse gases by 2020 and an increase of 20% in renewable energy by 2020. They're doing this out of necessity because they are short on fossil fuels. We need to do that intelligently because we have the foresight and with the willpower to make it happen. It's interesting how collective perceptions evolve. And that is, in fact, the greatest promise that we have. The issue, of course, is time. This telephone idea cannot be considered a serious means of communication. Well, that was Western Union in 1876. There's another interesting one here is the challenging the status quo. There's no reason anyone would want a computer in their home. Ken Olsen, incidentally, was voted America's most successful entrepreneur by Fortune magazine in that year, 1977. Needless to say, the solutions are so long that individually I don't have to go through them. You need to be curious and look for them. Electrical cars, at the very least hybrid cars, is a way of incentivizing car manufacturers to do more, to spend more in R&D. When you consider your next car, go with the times, because if you don't, you will eventually have to catch up, and when you do, you'll realize, why didn't I think of this 4 years ago? Because you'll be saving a lot on gas, you'll be feeling good driving, you'll be reducing carbon emissions, and you'll be sending a strong message to the car manufacturers. The solutions lie mostly in the middle of our conscience, between our imagination and greed. But neither have to be compromised. Economically, we can actually promote a sustainable and renewable market without necessarily compromising our comfort. The climate change is the one link that connects us to nature. If it breaks, we break. Currently, there are 900 million people who are going hungry and 2 billion people who are malnourished. Each degree of rise, we lose 10% of global calories. 4 degree of rise would be 40% of global calories. 2 degree of rise by mid-century would be 20% of global calories, and 7% of water for each degree of rise. And that's just for human population. Just think of what it does to the animal world. It might help frame what would happen to the rest of the species. At current growth rates in our habit, we have exceeded our carrying capacity. This needs to change. We really need to reconnect emotionally with nature in order to understand the role that we play in it. We have to evolve into a new collective consciousness and stop thinking in terms of life on credit. We have to understand the role that we each play within this paradigm, because we're not going to save what we don't love. So with that in mind, we need to reconnect with nature. I can see a future where cars are silent, emitting zero emissions, where packaging materials are entirely biodegradable, where the air is clean even in large urban center like this great city, where energy is drawn 100% from the wind and the air and the sea. We can change this socio-economic and environmental paradigm by supporting business leaders and political visionaries. We have to put our muscle behind people who are promoting change rather than supporting the status quo. It's really, at the end, up to us. The answer is right there. It's time for us to welcome this third industrial revolution. Churchill used to say that Americans always do the right thing. It just generally takes exhausting every other possibility before getting there. Well, I hope we don't have to wait that long. We've got about 30 years to get it done. Thank you very much.
Thanks. The compelling nature of your presentation speaks for itself. My question is, practically and realistically, haven't we already passed the tipping point? I saw James Hansen recently say that even if we stop putting even 1 more ounce of CO2 into the atmosphere tomorrow, that the temperature has only risen 50% of what it's going to rise based on the CO2 that's already there and will stay there for another 1,000 years. And he says, based on that, if it is only 50%, the temperatures will rise 7 degrees Fahrenheit by the end of the century, which would be the catastrophic outcome you described. And if that's the case, what are we talking about? Yeah, well, that's always, of course, one of the right questions to ask.
The simple answer to that is that if you're headed at 100 miles an hour into a wall, you have two choices. You can say that at 100 miles an hour, there's little chance that you'll survive, so keep your foot on the accelerator. Or you can start applying the brakes and hope for the best. The reality is we're already storing 5 times the amount of energy required to actually reach that 2 degrees Celsius mark. And we're still exploiting fossil fuels around the world. So there is a very dynamic chasm between reason and this sort of insane path that we're on. But if we don't begin a process of accountability, of asserting, and of exploration of solutions with a global commitment to doing so, we'll never know what that answer is. We certainly know what's going to happen if we don't do anything. The next step is to try something and hope for the best. Well, so on a positive note, because it's very easy, to be pessimistic, and I always have that horrible feeling that I give these talks and essentially I'm responsible for the depression and the shrink bills that come with it afterwards, and parents or wanting to be parents, examining the nature of parenthood as a result of that. The reality is I've been an advocate on climate issues since the late 90s, and I was exposed to climate issues by some very intelligent people, and it resonated strongly with me. And at the time, there's no question that we were living in a tree-hugging environment. That all the while climate considerations had been, Jim was, of course, on it for decades before that, but that on the whole, the nature of collective consciousness on the issue was quite limited. And over the course of time, I've managed to see some incredible breakthroughs in terms of awareness. The very fact that we sit here in this room. I gave lectures in 2004 in Europe with college-educated people who looked at me with round eyes when I mentioned global warming, which was a vernacular that to them, college-educated individual, sounded more like longer, lazier summer and milder winter and didn't sound so bad. And then Katrina happened in 2005, and with Katrina came a complete transformation in people's awareness of the issue. It became a kitchen sink conversation. It was, in fact, even after that in schoolyards. And now, of course, with Sandy, we've had just a renewed sense of awareness on the issue. President Obama is now mentioning it in his speech on Monday, and we have the issue being brought to the G20 and the G8 meetings, and global leaders are actually talking about it. The issue is on the table. So it's important to put that in perspective, because 2005 was only 7 years ago. And 2005, we were really in the dark ages as far as awareness. So with that in mind, we've seen a transformation of the car industry, and we see a much stronger sense of advocacy, of awareness, of engagement by individuals, and as well by economic leaders. In trying to bring forth new modes of energy. Of course, we're fighting tremendously powerful lobbies with a lot of money, and that will be, in fact, the mandate of this next 4 years, one hopes, is to try and scale back on the subsidies for these energy companies. Those are all the steps that sort of lead us to a program of change. And if you look at where we were 5 years ago, whence we've come from and where we are today, I think it's reason enough to be optimistic. And of course, if we contemplate some of these statistics as far as the stored fossil fuel energy that we have relative to, to the projections by the IPCC of where that's going to lead us, it's easy to be depressed. But our only source is this dialogue, is this engagement. Every time you get a message on your email saying take action, sign here, listen, just sign it. God knows if it's going to make a difference, but you'll never know unless you do it.
I want to thank you for mentioning electric cars. Full disclosure, I sell electric cars and I sell solar energy. But I did so because 10 years ago I bought a solar system and installed it on my house in Santa Monica. Then I bought an electric car, so for 10 years I've been running my house and my car on sunlight. I've driven 123,000 miles in that time. So cars now, as you mentioned, the car companies are building these cars. 2 years ago, we had 3,000 electric cars in this country. Today, we have 70,000, so in 2 short years. So we now have the first used electric cars coming on the market. So price is no longer the consideration it was before. You can now buy a perfectly good, functional, phenomenally good car for under $20,000 that runs on sunlight.
Yeah.
So I want to thank you for mentioning them, because so often when I go to these talks, they never talk about that. They talk about what you should do, what the government should do. But 90% of the pollution that you in this room are responsible for comes from your home and your car. Solar energy is now cheaper than grid electricity in Los Angeles and most of California. If you have the roof for it, put solar on, lease it. You don't even have to pay for it. You just lease it. No money down at all. And you're making money from day one. So you've eliminated the pollution from your house, except for the natural gas part for heating and cooking. But that's a small part. Then the second thing you do is the next time you're in a market for a car, make sure it's got a plug on it. Do not buy a new car or even a used car at this point unless it's got a plug on it. Keep what you've got until you can afford a plug-in car. Get it and make sure it's running on renewable energy. At that point, you've eliminated about 90% of the pollution that you are responsible for the rest of your life.
Yeah, excellent point, and thank you for bringing this up. The solar panel, it's true. I mean, this is the progress that we're experiencing as we speak. Is solar companies will lease a solar panel that will cost you nothing, in fact, to install, from what I understand, and they'll ask you to provide them with a bill of your energy use, and they'll just match it, and that's it. And so if you own your home, the barrier to entry is really, really low. And as this gentleman said, this is just an easy way to make a little commitment that makes a big difference.
It seems obvious that climate change is a symptom of the real problem, which is overpopulation. Until we tackle that, we're just treating symptoms. Why aren't you speaking more about that?
Well, I did bring it up, in terms of those earlier slides. We're obviously 7.1 billion people today. We're 1.5 billion 100 years ago. Life expectancy is just about double what it was 100 years ago. There is a natural filter that is taking place. In fact, a couple of years ago, Australia ran a pilot program where they actually taxed families for having more than one child, which is the first time in history that something like this was done. Traditionally, people celebrate newborn into family. This goes back, of course, for millennia years, because this was more labor and a stronger structure, family structure, et cetera, et cetera. And then this is translated into modern societies where governments subsidize families with more children that they have. And this was the first time that actually a government was looking at taxing people for having more children. In reality, you don't actually have to create a pilot program for something like this, because it's already happening. It doesn't take a genius to figure out how much money it will take to put one child through college, or even through just regular education. And the more, if you multiply this by 2, by 3, there's no amount of money that the government is giving you today that's going to balance this negative imbalance. So, controlling demographics is always a bad word. I mean, we see what perceptions are like in China when they've implemented this program, which seems to all the rest of the world as an inhumane way of addressing demographics. The reality is, economically, and we're seeing it right now, this is in fact taking place by itself. There's not much that you can do to control the freedom of individuals to have less children. Education, of course, what we're seeing right now in terms of birth control in developing countries and whatnot is contributing greatly to a projection of reduction in demographics. In Western countries, unfortunately, the very nature of democracy, thank God, and sometimes at some other cost, is preventing us from doing more.
Oh, okay. If we're at roughly 390 parts per million, and we want to get back to 280, how many trees do we have to plant? Can we, are the forests kind of what one of the ways to, battle it as far as not only stopping output, but then reversing it?
Well, the first thing we should do, obviously, is to stop cutting them. And reforestation certainly the forests are the easiest and the most obvious of carbon sinks. This is part of the global commitment that needs to be implemented, whether domestically, of course. I mean, this country has seen a tremendous loss of its natural growth over the last 2 centuries. Essentially, 85% or 90% of its natural growth has been deforested in the U.S. alone. And needless to say, we know what's happening in the Amazons of Brazil, Amazon and whatnot, and around the world, and Haiti and places like that. So this is a carbon sink issue. It requires that level of commitment to conservation, to reforestation, and once again, it's both. It's a combination of advocacy, of governance, and of leadership. Yeah. There's no simple answer to that one, I'm afraid. Yeah.
Are there any far-fetched ideas that are floating around? For example, a telephone or a home computer that might be put into action. I have heard that there was someone in England that was offering $10 million to someone that could figure out a way to stop the growth of this unlivability. I don't know, it seems to me I remember like a white towel around the entire Earth, and I also did hear that when during the 9/11, the week following it, there weren't any planes in the air, so it affected the entire ecosystem around the Earth. So how could that be implemented in a way, just purely scientifically, as a possibility to slow everything down? Possibly. Do you hear these kinds of ideas?
Well, yeah, you hear these ideas. I mean, look, I'm not a specialist in news media specifically when it comes to great ideas like this. I read the papers, and so I hear some of them. Some of these ideas are really far-fetched. I hadn't heard the towel around the planet. Yeah. Buckminster Fuller, I think he's come up with some ideas like this, but I'm not really too sure.
In your opinion, do you think people making different food choices will have an impact on reversing some of these trends, like being vegetarian or vegan? Like, could you speak more to that?
Well, yeah, absolutely. I mean, this is a whole other chapter in conversation, but thank you for bringing this up. Needless to say, meat, of course, is a tremendous creator of greenhouse gases, and not just because of the methane that it creates, but of course the grain, the feedstock that it takes, the transportation of the animals, the refrigeration of that meat, the transportation to stores, etc. So yes, there's no question that that meat increases greenhouse gases. In fact, I believe that it accounts for about 20% of greenhouse gases. So it's a very large portion of it. And as far as as far as organics and organic food and vegan eating and whatnot, I mean, the genetically modified organisms are destroying the sort of the natural cycle of food production on this planet, and little by little, it's actually eating at natural cycles and reducing the biological diversity in food to controlled substances. And if we're not careful, it will actually potentially run the risk of not only just being controlled by entities, but also being susceptible to being wiped out and therefore destroying 15,000 years of farming development that we've experienced on this planet, because a cold spell or a virus could destroy a food stock that's been genetically engineered and whatnot. So this addresses a different type of question, which has to do with anthropogenic footprint on and our ability to survive within our agricultural and cycles. But the meat is a great point. Yes, meat does increase greenhouse gases. So eating less meat. In fact, I had a friend who had a program called No Meat Mondays. And for the meat eaters out there, we actually practice that. We don't eat meat on Mondays. I'm a meat eater, but don't eat very much of it. But we don't eat meat on Mondays. Why don't you try it?
Ruling out politics, which we're all sick of, can you think of any scientific reason why solar was excluded from the federal rebates in the fiscal cliff legislation?
You know, that's a great question. In fact, solar is a great question that in many ways is symptomatic of the of this great divide, paradigm that we live in. Solar was invented in the U.S. It's a U.S. technology that essentially has been lost to the Chinese. No offense to the Chinese, but they own that industry today. It's an industry that we could very easily reclaim as American-made. Now we actually import most of our solar from China, and the world as well imports most of its solar from China. In fact, Germany imports most of China's solar. So this is definitely an area that could so easily be not just a job creator, but also do good for the planet. And really, this has to do with a reshifting of sensibilities in Washington and being able to override the power of the energy lobbies that basically control those types of decisions. I mean, listen, I think what happened on November 11th is certainly one foot in the right direction. I think that the alternative would have been a very, very challenging 4 years for the environment. So all we can do now is there is some momentum, and is to just push forth. You know, Eric Garcetti is running for mayor. Eric Garcetti has got a great track record on environment. He's a good man. You know, you may find somebody else whose agenda is on environmental issues, in which case pick the right person. But in my opinion, you should, and you are somewhat morally held to supporting individuals who put the environment at the forefront of their policy making.
Hi, thanks for your talk tonight. You kind of touched on this, but I wanted to just bring up the divide that has been created in politics, just about like general beliefs on what's causing global warming, and how that has become just such a political, social, and but especially political divide. And I was wondering what you think about kind of addressing that and kind of trying to break that down.
You know, earlier in the talk, I was making some references, some historical references of these sort of psychological and sociological processes that take us into cycles of denial, and often those are based in they can be based in a variety of of different sources. Some of them are as simple as ignorance. Others are driven by gain or profit or economically motivated. Certainly, when people have built businesses over the course of a century using certain types of energy as a promoter of their business, and they've invested tremendous amount of R&D and resources, and are making enormous profits out of it, they are not likely to want to walk away from the pot of gold. So we have lived through 30 years of deregulation in this country. We've inherited a lot of deregulation from the Reagan era. We live in an era, in a period, in a time in our history that requires more regulation. And whether we like to admit it or not, individuals and business leaders are not going to be driven to reduce their profits just on moral grounds. It has to be controlled. It has to be efforts have to be subsidized when they're the right efforts, and individual businesses have to be rewarded for their policies, their corporate social responsibility, but mostly environmental responsibilities. and those who are detrimental to the general health of communities or societies have to be taxed and have to be in some way or another, incentivized to change their ways. So coal is, one of those industries in this country which has thrived since the Industrial Revolution and still has tremendous amount of resources available, and for many people is making a lot of money. And incidentally, this can be very insidious, because you may very well, as a environmentally interested individual, be actually investing in some of these energies because you're not entirely sure what your portfolio is investing in, if in fact you have one. And I bring this up simply because sometimes it's so embedded in in a sort of an obscure cycle of investments that you're not even sure that you're supporting it. So once again, curiosity, commitment, advocacy, engagement, all those things will help in correcting that. And no business leader wants to be the one facing a shareholder meeting and tell them that they're going to be losing money in the next 10 to 15 years, but that 15 to 20 years from now, they'll be sitting on top of the world, because the shareholders tend to look at this and go, you know what, get rid of this guy. I'm building a new kitchen right now. I need that money right now. That's the challenge, and that's why governments have to step in to incentivize businesses to do the right thing. Okay. So thank you very much.